Hello. Today I'm going to show you how to build and add your own ProMAX socket tool to the processes list and have it available for use for processing. The first thing we do is we have to set up some environment variables to facilitate the use of our own personal development environment, and then we have to specify the path by which we're going to build that personal development environment. What we're seeing here is a list of some environment variables I normally set up, like ProMAX home, prowess home, path, and an environment variable that's used by the SeisSpace interface that says where is a user's particular development environment path. And in this case, it's going to be home, ProMAX home, and then by default, that is the path you get when you install SeisSpace. I set up other aliases like for gmake and a few other ones to allow me to navigate around my directory structures easily, making my life a lot simpler. Okay, the first thing we'll do is come over and we will source that bash script to set all of the environment variables. So if we do env pipe grep ProMAX, we can see that ProMAX home is set, my ProMAX home is set, etc. One of the things I do first off is to check to find out if all the RPMs and packages are loaded for development. And we do that by running the script called prowess home etc check packages, and if you give it a command line argument, any command line, like D for development, it'll go out there and check additional packages, more than just what you would check for normal SeisSpace. And you can see it checked out there to make sure that Swig, GCC, Fortran, all these were there. Okay, so once we do that, then we can run this script called make advance, which builds a directory structure underneath your home directory that mimics the software directory structure of ProMAX. So you can see we have home, and then what my ProMAX home is, or what ProMAX home is. So if this ProMAX home is here, my ProMAX home is home, ProMAX home. And is that okay? Yes, we're going to create it there. We're going to check. There's only one platform to select. Is that okay? Yes. So it goes ahead and copies all these files and build these directory structures for our dev kit. So if I say go my to exe, if I see what the aliases are, my exe says cd to my ProMAX home port source exe, and that's where I'm at. So I go to, if I just do an ls and see what all socket tools are there, here's all my socket tools. So let's go to amp ratio, and here's all of our files. So we have our source code and our make file, which helps us build the code, and the menu file that we're going to need. So I'm just going to run gmake to go ahead and compile and link the source code. Okay, so it looks like we built our code out there. And we're currently in this directory. So let's go up to my menu. And we're in my personal menu, and let's go to ProMAX 3D. So this is where all the three menus would be. And let's copy that menu file from the source tree to here. Okay. And then I'm going to copy from my temp directory a processes list that I've created previously. So in this directory, we have these two files, and if we just do a gedit, let's just VI on it, on that file, what this does is this tells SeisSpace interface the name of the category for the tools, the name the user is going to see, the menu name, and in this case, we're going to allow it to be incorporated into a parallel hybrid flow. So this is an example or a short version of a processes PM. You notice we have to have this little quote at the top and then the right number of parentheses around the outside. So once we've done that, then we need to take a look at our SeisSpace startup script. And in this case, what we tell our SeisSpace startup script is what my ProMAX home is. In this case, it's home ProMAX home. So we will look down this tree for additional menus, executables, processes list, etc. Okay. So now let's go ahead and back and execute that flow. Okay, and then we'll just run this particular script, not execute the flow, but run the script to start SeisSpace. Right, so if we now look at here, we have the user, SeisSpace 3D, user dev tools, and our particular amp ratio. So if we just use synthetic trace generation and add that in there and bring in amp ratio and then say CED trace display. So what amplitude ratio does is it simply scans down, it takes two windows and scans down the trace and looks at the ratios of those two windows and plots those ratios on the, and what you're really looking for is where is the first break. So if we go ahead and execute that flow, there it is. So you can see that particular line going down. Let's see if I can draw right there. That is where the amplitude ratios are maximum, and that happens right at the boundary between the pre-first break noise and the first breaks, and it goes away once you get into the data itself. And that's it.